So we will see today numericals. Numericals on main dimensions we will do. Numericals on main dimensions, overall numericals means everything will get covered over here. So let's see. So we have so calculate the main dimensions. Calculate the main dimensions turns per phase. Calculate the main dimensions turn per phase. Number of slots. Number of slots. Conduction cross section. Conductor, that is the cross sectional area. Conductor cross section. Conductor cross section and slot area and slot area of a 250 HP of a 250 HP 3-phase 60 hertz 3-phase 60 hertz 440 volt and 1410 RPM 1410 RPM induction motor. I'm writing that is delta connected. The machine is delta connected and for the following data. So the data available with you is that average flux density, that is average flux density, V average. This is called average flux density is equal to 0.5 Weber per meter square. Okay, this is average flux density. Flux B average, this would be equal to flux by area. Okay, that you know already. Average flux density is this much, and specific electric loading, that is ampere conductors. Okay, this is right with a different color here, so that so specific electrical loading. The specific electrical loading is nothing but as ampere conductors is equal to specific electrical loading is equal to 30,000 E0 0 okay 0, that is 30,000 ampere conductors. Okay, this is equal to 30,000 ampere conductors per meter. Okay, and efficiency of the machine, that is your efficiency of the machine is equal to 90%. Efficiency of the machine is equal to 90%, and your power factor of the machine, power factor is equal to 0.9. This is the power factor is equal to 0.9. Winding factor, that is your kW, winding factor kW, this is equal to 0.95. This you remember, if it is not given, you take it 0.955 or 0.95. Current density, your current density, okay, this is the symbol for the current density, is equal to 30.5 ampere per millimeter square. 3.5 ampere per millimeter square. Okay, slot space factor. Okay, so this slot space factor is equal to 0.4. Ratio of core length to pole pitch, that is length to pole pitch. Pole pitch is what? Pi d by p. Length is L. Okay, so this is saying ratio of core length to pole pitch. Pole pitch is equal to 1 is to 2. 1 is to 2. Okay. So, like, first of all, we know the given data. Okay, this is the given data. If we want to write, so we'll write the what is the given data. First, whenever you go to any examination, tomorrow you might have to write a gate examination or any other competitive examination. So develop an habit of reading the question once or twice before answering it. You may think time is less, but if you rush to the answer, you will 90% of the time you'll go wrong somewhere. So you just try to hold the question in your mind. You have to take into account everything. See, check the dimensions. Whether this is millimeter square, centimeter square, you are getting them right dimensions, other factors. So you have to do a problem not in a hurry burry, but with a cool and patient mind, just like Rahul Dravid used to play. You should not like hit the ball like this is a very easy question, not like that. So most of the times it happens. So when we get complacent and we miss certain points, and it results into like in a competition in an objective type examination, if you one mistake is done, then it's gone. But that thing you have to keep in mind. So given data, so first of all, you read the question. Your power is equal to 250 HP. So power horsepower given. Okay, so it's given here 250 HP here. Okay, then this is a three-phase machine. Three-phase, okay. It's not a single-phase machine, so all the formulas will be for three-phase. And one more thing, it is delta connected. We have to take V line would be equal to V phase. Okay, 50 hertz. And its voltage ES, we need not to divide it by root 3 because it is delta connected. If it was star connected, then this ES was 400 divided by root 3. So there also one mistake can happen. So N is equal to, this is your speed for 1410 RPM. So again, then your efficiency is equal to 90%, that is zero point 0.9. Your power factor is equal to zero point 0.9. This has been given. Then your power factor, that is your cos phi. Then kW value is given. Kw is equal to 0.955. Your current density value already given, 3.5 ampere per millimeter square. And then the other factors, your space factor, that is SF, is equal to 0.4, and your L by Z ratio, that is length to Z, whereas this Z is equal to, this Z would be equal to pi d by p. Okay, pi diameter pp. L by Z ratio is given 1 is to 2. So what is the thing that you need to calculate from this particular thing? What is the thing that you need to calculate? So what is the required thing? What is needed to be calculated? Okay, so required data, what is the required data, what you need now? So that thing you have to understand. Main dimensions means d, they are asking for d diameter, they are asking for the length. Okay, then they are asking for the turns per, see, ts value, they are asking number of turns per phase, they are asking number of slots, stator slots you require. Okay, then you require area of that slots, and then the DSS into WSS is required. These are the things that you require. See here, calculate the main dimensions. So main dimensions will come D and L, turns per phase TS, number of slots SS, conductor cross section AS, and slot area of slot area. This is for slot area. Okay, slot area. So once you write a question, you can write the given data and the required data, and then you go for it. Then it will be very easy compared to just starting away with some random data. So now you know that. So once you know this thing, so you have certain formulas in your mind, you can write those formulas. So your input kVA, if you write your input kVA, so your input kVA will look like 0.746 into HP. This is the formula that we have seen previously. previously also. Okay, so this 0.746 into HP divided by your efficiency. So your this input kVA would be divided by your efficiency. So this input kVA value you will get, and once you get this input kVA value, so how much will be the input kVA you calculate. Okay, now the output, this is input kVA is, I think, how much, not calculate output coefficient. So you go for the output coefficient, that is your C naught. C naught value, 1.11, okay, pi square into BAV into AC into 10 power minus 3. So all the values are there. BAV value is given 0.05, AC value is given 30,000. You substitute over here, so it would be 1.11 into pi square into BAV value is given 0.5 into ampere conductors value is given, that is 30,000 into 10 power minus 3. So once you get this value, it would be around, calculate this value and let me know your input kVA. What would be the expression for the input kVA? Yeah, I need this time you have to solve this. I have solved so many problems for you. So try to solve this by this time you should be able to do. So yeah, tell me what value you are getting for output coefficients. See, one thing in this problem, the number of poles he has not mentioned in this problem. So we have to go to calculate the number of poles. So number of poles, he has mentioned the speed in terms of RPM, not RPS. So here we cannot apply 2F by N. Instead of that, number of poles would be 120F by N. So 120 into 50 divided by 410. So it comes around how much? So your input kVA value, you tell me please. You are getting how much value you are getting input kVA? See, if you do 250 into 0.746, how much you are getting? Hmm? Tell me.
186.5,
Do two,
sir.
186.280 into point. Okay, then divided by 0.9.
Sir, 207.22, sir.
207.2. So input. See, basically, I've showed you input kVA is equal to 0.746 into HP. Again divided by 0.9. How much you are getting? 207.6 you divide by 0.9. How much you got?
230.24.
230 point. So input kVA formula is what? Input kVA formula is 0.746 into HP divided by efficiency into cos phi. Okay. See, by this time, okay, you're not like, see, if you go back, most of the videos what I try here, some people cannot access, so I try to put on YouTube also, so that like on YouTube you can open and check. So every formula I have mentioned over there also. So here, see, these formulas should be in your mind now. Okay, you have to tell me, sir, you forgot to write cos phi there. So that's why I'm seeing if time and again I am only writing, I am only reading, I am only doing, so it is not good. So this is 0.9 into 0.9. Okay, so this comes around 230.2. Okay, and this value you calculate and tell me please. Hmm? Tell me. This value would be around, yeah, 156.93. This value you get around 156.93. 156.93. Okay. Now the thing is that the number of poles, okay, the number of poles, number of poles would be equal to 120 F by N. So 120 into 50 divided by 1410. So your number of poles would be how much? It comes around, number of poles will be 120 to 410, it will be around 4.25. But can we take this 0.25? No, we, because the poles have to be a real number, an integer number. So the nearest number would be 4. So therefore p is even number, since, and it has to be an even number. Poles cannot be because odd number, because always they are in pairs. Okay. Why some, if it comes 4.75, that means you can take 5? No, still you have to take 4, because if it comes 5.75, then you can go for 6. Okay, it has to be, p has to be an even number. P has to be even number. So that thing you keep in mind while calculating this. So then the synchronous speed of the machine, if you have to go for the synchronous speed, that would be ns, that is the synchronous speed of the machine. So this formula you know is equal to 2f by p, synchronous speed, because this synchronous speed will be in rp. Yes. So this 2 into 50, number of poles you calculated 4, so it comes around 25. It comes around 25 rps. Now you calculate, because why you are doing all this jagran? First of all, you have to calculate the d and l value. So we know the d and l value has some relationship with respect to these factors. That is your d square l, that we saw that d square l is equal to input kVA divided by C naught ns. So input kVA we calculated here, okay, C naught we calculated here, ns now we calculated. Now we will substitute the value. So input kVA value is how much? 230.24. Okay, divided by C naught value you have to substitute. C naught value is 156.93 and your ns value is 25. Okay, is it? So you tell me the value. Now you calculate it and tell me. Yeah, Manohar, how much value you are getting? Yes. Uh, there are like tomorrow Saturday.
0.0.
So, huh? How much? 0.0587.
Yes, sir.
Are you getting this? So 0.0587 meter cube. So tomorrow again, I will like, tomorrow is Saturday. Monday, I need 3 people to deliver in the beginning only, flip class. Okay, so I'll write down over here the names. Manohar, you have not given. Okay, Manohar is not given. Then one more person who has not given flip class. Okay, so today Ajit Kumar, you have also not given flip class. Ajit Kumar, Ajit Kumar. Okay, then number 3, Noor, have you given your flip class?
Yes, sir.
Noor has given, huh?
Yes, sir.
You have finished with your flip class. Afsa, Afsa,
She
Afsa has
also.
also
Afsa,
given,
Afsa
sir.
is not there.
So she has also given.
Afsa is also. Bhavna M Shetty, you have not given, huh?
Yes, sir.
Bhavna, okay. Bhavna, you have not given. So you be prepared, okay. So Manohar, I will like Ajit Kumar and Bhavna M Shetty. So Bhavna, Manohar, you explain the magnetization current, okay. Magnetization current expression, okay. Expression You explain me the Ajit Kumar bar current, okay, bar current of induction motor, and and uh, what entering current, okay. And you Bhavna and Shetty, you explain me the total copper loss due to bar current and entering current. Okay, I'm writing it over here. Current. Okay. So this thing I'll take a snap also, so that so you have to be present. Hmm? This thing has been written already. Okay. So now this thing you remember, oh, these three people are there. So as far as this thing is concerned over here, so we have to now it will come around this value. So once this value comes, so we have one more thing. We have the L by Z ratio that has been already mentioned. So the L by Z ratio is being mentioned as 1:2. Okay. So that is good. So one more thing we know that uh, the Z is nothing but pi d by p. Okay. Pi d by p. So p value we know is equal to 4. Okay. So we can write L is equal to 1/2 into p divided by pi d. Okay. P value is 4. So if we substitute here, L is equal to 1/2 into 4 divided by pi d. So this value 2 2 are, so this is 2 by pi d. 2 by pi d. 2 divided by pi d, this will come around 0.942d. Okay. So this will come around 0.942d. And on top also we have the value d square L value was equal to, we also have d square L was equal to 0.0587 meter cube. So now from substituting these values from the 0.027 in this value and this value, so putting the value of L in this equation, so this value if we put here L value, so we get around d cube 0.942 would be equal to 0.0587, and you can calculate the value of d, that will be cube root of 0.0587 divided by 0.942. This value will be around how much? So from here you will get the value of d. The value of d would be point, how much it is? Yeah, calculate the value of d. It would be 0.3964 meter. It would be, now the d value would be around, d would be 0.3946. Similarly, you can substitute and get the value of L. So the L value is 0.942 into this 0.942 into 0.3946. So this value will be around how much? 0.373 meter. So you got this, you got this value, you got the D value and the L value. So first part of the question you have done. So the first part of the question that required you is to get the D and the L value. So calculate the main dimensions you have done. Okay. Now turns per phase. Hmm? Now you have to move for the turns per phase. Now in order to get to the turns per phase, how do you go about this problem? See, oh, you, one thing has been mentioned over there is your average flux density has been mentioned. Okay. Before going to the turns per phase, you know that your number of turns per phase, if you write the EMF equation, that would be equal to 4.44 F phi m kWs into Ts. Okay. So you know that you have this value of Es over here. Es, that is equal to 4.44 F phi m kWs Ts. or in other words, your turns per phase would be equal to 4 uh, would be equal to es divided by 4.44 f phi m kws. So all the values are there except of this phi m value, because but we are being given with b average. So in order to calculate, b average is equal to phi m by area. So in order to calculate phi m, so you have to multiply b average with the area. So how now the to calculate the area, now you only value you what you need is you need the value of area. So in order to calculate the value of area, so you can write in terms of area. So you need to calculate this value. So you can write b average. Okay, area would be equal to pi dl by p. Okay, because it's a cylindrical, so area per pole you have to, because the maximum flux per pole it is. Okay, so it would be area is because of the cylindrical, that is dia and length. So your area here, this would be equal to pi dl, and per pole pi dl by p. So total flux now your total flux now would be equal to, so your phi m would be equal to bav into pi dl by p. So bav value is given 0.4.5, pi value p value 4, d value we just now calculated. You have calculated the d value, okay, 0.3964, and l value also 0.3734. So 0.373, okay, 0.3964 into 0.373. So once you have calculated the value, so you'll get around the maximum flux value, you can get around the phi m value. So how much would be the phi m value? Phi m value would be 0 divided by 4, that is 0 point, this would be 0.0581. This would be 0.0581 Weber. So this value you have to substitute. Now you can calculate the TS value. So TS value would be equal to how much? TS value is, again the formula I'll write for your convenience. ES, okay, 4.44 into F into phi m, okay, into kws. So here this is 400. If it was, why this is 400? Because it is delta connected, and in delta your
440, sir.
huh,
440, sir.
it is 400, 400 na,
You said
400.
440 in the question, sir. So
No, 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 no. 440, eh? Oh, 4, okay, 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 440. I'll just see the question once more. It is, sorry, it's 400, okay? This is a mistake. Huh? This is the question only where I was just lifting the question there. It's 400, okay? If it was 440, it would have been 440. So you take it as 400, okay? This ES is equal to 400 because it was delta connected. If it was star connected, then it was 400 by root 3, okay? This would be 4.44. This is 50. This value is 0.058, and this value 0.955. See, the aim is not the numerical value. The aim is to understand the concept, how you have done. So if you have taken 440 also because it was written in the question, then the answer is like that only. Okay. So I made a mistake while lifting the question. I just looked back at the question on my notebook. It was like, because you have to transfer it from notebook to that place. So sometimes these errors happen. Okay. So this will, now you get a value of TS. So the value of TS when you are substituting all the values will be around 32.47. But TS is the turns per phase. It cannot be in a fraction value. So we will take the nearest number, that is 32. So once we are seeing it, so it is coming around 32.47. So that is like equal to 32. Okay. because turns per phase has to be an integer. So now we have done with this problem here also. We have done with, we got the turns per phase also. This expression also done. So turns per phase also we have done. Now he is asking for the number of slots. Now in order to go for the number of slots, see, before going to the number of slots, see how much total number of conductors would be there, that is Zs. If we got the value of Ts, tell me how many Zs values we will get. Hmm? Tell me. Tell me, please. Hmm? Yeah, tell me. See, total number of conduct. If Ts is equal to this much, how much is Zs in terms of Ts? Huh? Anyone can tell. So many times I have told this Zs would be equal to, yeah.
60,
Tell
sir.
me. Ah, very good. You have to tell now that then only teacher will get confidence that what he is teaching, students are following or not. You should not be okay. Even if you are wrong, no problem because you are learning it for the first time. So 6 into 32. So you get this value of ZS. 6 into 32 and you'll get it 192. Okay. So this value you got 192. So now let's assume this winding to be, because mostly now I have told you in the very beginning of induction machine, see the rating of the machine, how much it is. 250 HP. Is it a small machine or a big machine? It's a big machine. So for a big machine, what type of winding we take? We take a double layer winding. Okay. So hence it's a big machine. So we have to take a double layer winding, and it's this is your um, its circumference divided by stator slots. That is equal to stator slot pitch. Okay. It's stator slot pitch, which is given by this YSS. This is nothing but as stator slot pitch, which is stator slot pitch is pi d, that is the total circumference, divided by what? Pi d by the SS. What is SS? SS are stator slots. See here you saw ZS. ZS is total number of conductors. Total number of conductors. See, and ZSS is ZSS is total number of, means how many conductors per slot. How many? This is conductors per slot. Means I will write I have slots, 72 slots, and each conductor is having 20 conductors per slot. So here your SS would be equal to 72, your ZSS would be equal to 20, and ZS would be equal to SS into ZSS. So here in this case, for example, in this case I have 72 slots and your ZSS is 20, so it would be equal to 1440. So this formula also you have, which time and again we are using in different stuff. So here let's select this as a double layer winding. Okay, so double layer winding, and in this double layer winding there is the 1.2, 1.5 to 2.5. So the ZSS is 1.5 to 2.5 MPQ, sorry, PQS. Okay, PQS already I have told you. So the Q value you have to always take greater than or equal to 2. So it cannot be less than 2 because it's the Q value. So when you are taking the Q value equal to 2, okay, so number of poles is how much? 4. So one thing will remain common. Okay, here one thing will remain common. You have this Q. Okay, this is the value that you have to choose, then number of poles and number of phase. Okay, this is poles and this be phase, so we can write MPQ. Okay, so this P, M and P will remain constant because m is 3 and number of poles are 4. Now the q value you can vary. Okay, q value you can vary. So q value you can vary. So see, you have to take the total number of stator ke kitne, how many slots are there. So in order to get that number of slots, what you have to do is that you know the value of ZS, okay, you know the value of TS, but you want to calculate SS. Now in order to calculate SS, let's see. So SS value, how you will calculate is, okay, let's see, the number of phases is 3 into 4. Now if you take the q value is equal to 2, so in this case you have 24 slots. Okay, now vary the value of q. Q is equal to 3. In that case, into 3. This will remain constant, 12 into 3. Okay, 3 into 4 will remain 36. In case of q is equal to 4, it would be 12 into 4. Okay, that is 48. In case it is q is equal to 5, then it would be 12 into 5, that would be 60. So now after doing all this, okay, now we have to see the value of stator per slots. So the range of this YSS range has to be between 1.5 to 2.5 centimeter. So this value. So YSS, I told you, is what is equal to your pi into d. That is your pi into d divided by your pi into d divided by your SS. So you SS. So this is in centimeter. So d value which earlier you got was 0.3964. That was in meter. So you convert, you multiply it with 100.3964 into 100. So this will become 39.64 in terms of centimeter. So you have to be careful. Now you substitute pi into 39.64 divided by your SS stator slots. Let's take the example for 24. So when we are taking the example for 24, so it happens to be around 5.19. Okay, 5.19 centimeter, which is not in the range of 1.5 to 2.5. So we have to make sure when we are taking, so the earlier this value will remain as it is. Let's take for this is case 1. Let's take for case 2, 39.64 divided by 24. Now when we are taking for the case second where the q value is 3, so what is the value we are getting? We are getting around 3 3.46 centimeter. Now let's do case 3, which again is not in the range, so we cannot take this. Now the case 3 into 39.64 divided by 36. So when we are dividing it by 36, sorry, first case was 24, this was 36, this would be 48. When we are dividing it by 48, what we find is that it is around 2.6 centimeter, not in the case. Now let's take the final case, that is 439.64 divided by 60. So when we are taking this case, so it comes around 2.1 centimeter, so it is good to go. So that means if we are considering number of stator slots, then SS is equal to 60 is selected. Why? Because the stator slot pitch has to be around 1.5 to 2.5 centimeter. You are getting my point. So now your number of stator slots is equal to 60 will get selected because of this. So you have to be very careful while doing this problem. So number of stator slots is equal to 60 is selected. Okay, now 60 was selected. Okay, stator slots. So that means SS value you is 60 is selected. Okay, ZS value you calculated 6 times TS. So ZS value 6 times TS was 192. Okay, now you if you want the ZSS value, so ZSS value also you can calculate because your ZS value is equal to SS into ZSS. So ZSS would be 192 divided by 60. Okay, so this value also you can 192 divided by 60. So this is around you will get around 3.2. So this nearest you will take an even value, that is 4. So number of stator conductor per slot is equal to 4. Now if you want to calculate the value of zs, okay, on this basis, now with this you calculated the zs value, okay. On this basis, if you want to calculate the zs value, so let's see on this value on this basis the zs value again. Now this zs value 192 you got from 6 times ts value by calculating the ts value. But on this basis, if you want to calculate, see, zs, this stator slots is equal to 60, okay, into 4, so you get 240. This zs is slightly, now you will say, sir, what formula you are telling, that is 192, this is 240. See, we are optimizing the design, okay. That the range of the design is from 1.5 to 2.5. So at the 60 slots, we are getting 2.1. Now if I further increase the number of slots at 72, I'll get a better range, I'll get it even less in that range. But the number of slots will increase dramatically, 12 numbers, and the copper area, the wire, everything will increase, so I have to optimize the cost. So this is like the number of turns, that was the actual number of turns, but this is the optimum number of conductors. Optimum means what I'm actually going to design. So that's why that variation you are seeing over there. So already I have also one more thing why it is coming is that I have taken 3.2 to the nearest value 4. Otherwise if I keep it to 3.2 it will come same. So again, if I want it to number of stator turns per phase, again if I want to calculate on this basis number of stator turns per phase, then it ts would be zs by 6. So number of stator turns per phase, so ts if I want to calculate, that would be zs by 6, that would be 240 by 6, that would be equal to 40. This would be equal to 40, okay. Now now, one more thing that has been asked to me is the stator current per phase. So, stator current per phase is equal to input kVA into 10 power 3 divided by 3 times ES. So, this once I get the stator current per phase, one more thing that is asked to me is the cross sectional area of each conductor. So, cross sectional area of each conductor, if and the current density is given. So, current density is equal to current by area. So current density is what? Current density is current by area. This is equal to area. So current density is equal to area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area into area, that is area into area. So area Yeah, are you able to hear me? Are you able to
Yes,
hear me?
sir.
Okay, okay, sorry.
Yes, sir.
Yeah, yeah, yeah. So now the last part only, we are left with the last part. So I'll just wind it up. So now we have to calculate this current, stator current. So in order to calculate the stator current, so we will straight away write down the formula, your input kVA. That is nothing but your, what happened? Wait, okay. That is your uh, input kVA divided by your, what is that value, into ES, input kVA into ES, that is your stator voltage. So input kVA, this is ES into IS in 10 power, that would be your stator current if you want to calculate in terms of that. So tell me, that would be your input kVA into 10 power. This if it goes down here, so basically your kVA would be equal to ES IS into 10 power minus 3. So this ES IS, so what I have to do is that this is the input kVA, okay. So from this equation, if you write this input kVA in 10 power 3, and because this is the three phase, so you have to take into consideration this 3. So this would be 3 into ES. So 3 into ES is 400. Okay, input kVA value you just now calculated. You have to resubstitute in this equation. Once you are resubstituting in this equation, so you will get the value, input kVA value, you will get the stator current value. That would be your input kVA already, which we have seen in the previously we have calculated, that is 230.047 into your 10 power 3 divided by 3 into 400. So this comes around your stator current 191.27 amps. So once you get your stator current, then you have to get the cross sectional area, that is your AS. So your cross sectional area AS would be current divided by current density, IS by rho S. So this current density is given 3.5 and this is 191.27. So this 3 point divided by 3.5, so this will come around 54.82 millimeter square. So this is your current. Okay, then again, area occupied by the conductors. So area occupied by the conductors in a slot. So area occupied in the conductors would be AS into ZSS. So that is your 54.82 and ZSS value calculated for. So this is the total area occupied by the conductors in the slot. So this is the total area occupied. So area occupied by all conductors in slot and slot space factor. So you can get this value. You now DSS into WSS value you want to calculate. So this would be the area occupied by the all conductors in slot. Area occupied. You can give the attendance simultaneously by and leave all conductors uh, in slot divided by your divided by slot space factor. So this is space factor. So this is the area that has been occupied, that is 219.28, and slot space factor has also been mentioned, that is your 0.4. So you get this value, DSS into WSS value, you get DSS into WSS value is 548.2 millimeter square. So all the values, we see that we calculated everything. So if you look at the problem, so what was needed, D value calculated, L value calculated, TS is SS is done, AS done, DSS into SS is done, slot area also we calculated. So this is like how to go about the problem. So I'm a little bit sorry, inverter went all of a sudden it went down, so our supply was went, then it generator was, it's very cold over here in Kashmir, took some time to get started. So this is the class. So any doubts you are having, or you are having any doubts, tell me. Hello, hello.
No,
No
sir. No
doubt,
doubt.
sir.
Then you can give the attendance and you can leave for the next class. So I mark, please give your attendance. So I'll stop recording over here. Yeah.